Hello everyone, I am Dr. B. Vijay Babu. Today I am going to discuss the topic understanding the interrupts and polling. The topics interrupts and polling are important concepts in I/O communication of computer organization and architecture course. Let us try to understand the background of these concepts. We all know that many external I/O devices like mouse, keyboard, scanners, printer, etc. are connected to CPU or the processor, and these devices needs CPU attention for data communication and exchange from an I/O device. Let's suppose a CPU is busy in displaying a PDF, and at the same time let's also suppose if a request comes from a printer, that is nothing but an I/O device, to print something. Here, though the CPU does not have any idea when an event like printing activity from a printer comes, but the CPU has to respond to such unexpected requests from the I/O devices also. Interrupts and polling are the two ways to handle such unexpected events generated by the I/O devices that can happen at any moment while the CPU is busy in executing another processes. By definition, interrupt is a signal requesting CPU by I/O device to pay attention on the need of the I/O devices that automatically suspends the CPU activity temporarily and try to service what the I/O device needs. Here, we have to keep in mind that this interrupt request may come from an I/O device or peripheral device at any point of time requesting the CPU to process it. When the CPU senses an interrupt signal on the interrupt request line, CPU stops its currently executing task and respond to the interrupt sent by the I/O device by passing the control to the interrupt handler. The interrupt handler resolves the interrupt by servicing that particular I/O device or peripheral device. When I/O devices are ready for I/O transfer, they generate an interrupt request signal to the computer. Then the CPU receives this signal, suspends the current instructions if it is executing, and then moves forward to service that transfer request. But what if multiple I/O devices or peripheral devices tries to generate interrupts simultaneously? In that case, we have to set a priority among all the devices for systematic interrupt servicing. The concept of defining the priority among the devices so as to know which one is to be serviced first in case of simultaneous requests is called as priority interrupt system. This priority interrupt system method can be implemented by using either polling, which is a software method, and daisy chaining method, which is a hardware method. We can say that polling is the consequence of prioritized interrupts concepts. That is, polling refers to the situation where an I/O device is repeatedly checked for the readiness, and if it is not, the CPU or the processor returns to different tasks. Polling is implemented by means of a software program called service routine program or service program. Coming to daisy chaining method, it is a hardware method that involves connecting all the devices that can request an interrupt in a serial manner. This configuration is governed by the priority of the devices. The device with highest priority is placed first, followed by the second highest priority, and so on. There are two types of interrupts. The first one is hardware interrupts, second one is software interrupts. Coming to hardware interrupts, when the signal for the processor is from an external device or the hardware unit, then it is called as hardware interrupt. For example, when we press any key on our keyboard to do some action, then this pressing of the key will generate an interrupt signal for the processor to perform certain action. Hardware interrupts can be of two types. One is maskable interrupt. Maskable interrupt means when the hardware interrupts, or these maskable interrupts are nothing but the hardware interrupts which can be delayed when a much high priority interrupt has occurred at the same time. Coming to the non-maskable interrupt, they are the hardware interrupts which cannot be delayed and should be processed by the processor immediately. Now, coming to software interrupts. Software interrupts are the interrupts that are caused by any internal system of the computer system, and there are two types of software interrupts. One is normal interrupt. Normal interrupt means the interrupts that are caused by software instructions, and second one is exceptions. Exception software interrupts are the unplanned interrupts which are produced during the execution of some program, and they are called as exceptions. The best example is division by 0. So, let us discuss the polling method in detail. In polling method, all the interrupts are serviced by branching to the same service program. This service program then checks with each device if it is the one generating the interrupt or not. The order of checking is determined by the priority that has to be set. The device having the highest priority is checked first, and then the devices are checked in the descending order of priority. If the device is checked to be generating the interrupt, then another service program is called which works specifically for that particular device. Therefore, the basic point that distinguishes polling and interrupt is that in polling, CPU keeps on checking the I/O devices at regular intervals whether it needs CPU service or not, whereas an interrupt is nothing but the I/O device interrupts the CPU and tells the CPU that it needs the CPU service. Both polling and interrupts allows CPU to stop what it is currently doing and respond to the more important task. So, finally, the difference between interrupt and polling lies in this particular example. If or whether you are letting the bell ring and then open the door to check who has come, that is interrupt concept, and constantly keep on opening the door to check whether anybody has come, that means it is nothing but the polling concept. That's all. Thank you.